Understanding what surfaces look like at a very small scale is really important when you're conducting tribological investigations. So this is the room in the university which houses many of the pieces of surface characterization equipment that we have in nCATS, and I'll talk through each one. So the first is a 2D line profilometer. This is quite a traditional approach to characterizing surfaces. It can be very useful. And then this is actually a 3D optical profilometer. We also have another 3D profilometer that works using white light, but with a slightly different methodology. Sometimes it's actually necessary to change the surface to make things visible that wouldn't be otherwise. And this is an example of a surface preparation technique. This is a polishing machine, and it will polish the samples to a very, very fine mirror finish. And that will enable us, when we go into this room where all the microscopes are, to be able to see things that we wouldn't have been able to see otherwise. Things like the grain structure of a metal, which can be very interesting and useful when we're looking at what's happening. Another thing we can do to try and understand more about what's happening to our surfaces is actually try and indent them with a small piece of diamond and see how that material responds. We do that at very small scales in controlled conditions. No materials characterization facility would be complete without an SEM. That's a scanning electron microscope, and this is the one that we have access to in nCATS. In order to scan the sample needs to be placed in a vacuum, and that's what you can see happening here. So we're closing the door, and then the sample is moved physically to be put underneath the gun. And this is what the SEM will show you. Really nice, detailed, crisp images at very small scale of the surfaces of samples. We're looking here at the level of thousandths of a millimeter, so 1 micron, which is much better than what you can get with an optical microscope. And we're also able, with this machine, to be able to understand what that surface is made of. We can understand the elements that make up that surface, the chemical composition, which is very useful too. And now we're back in the main nCATS laboratory, lots of different pieces of equipment in here. And we're going to look at one that's very popular. This is the T77 reciprocating tribometer, almost always in use. We're able to apply all kinds of different loads with this one. It slides backwards and forwards across a plate, hence reciprocating, and you're able to use this dry or lubricated, as you see here, a little bit of lubricant or lots of lubricant. Very useful machine. Here we have the ascot, which is able to test how corrosion resistant materials and surfaces are. We also are able to expose samples to high levels of UV light and see how they respond in those conditions. We have an erosion rig which is able to fire small grains of sand at high velocity at samples and see their erosion resistance. And finally, around the lab, you'll see lots of high precision balances. This is a really simple but effective way of understanding during a test how your sample is changing, just by seeing how much mass has been lost. Although we have many excellent pieces of standard test equipment, sometimes it's necessary to actually produce a bespoke piece of test equipment to make sure that the real physical mechanisms in service are captured by the test machine. And this is an example of a miniaturized rail axle and bearing assembly. And you can see here this running in dynamic testing. And here we see the process of changing over one of the axles. With this knowledge from this bespoke test rig, it's then possible to start to understand a bit more about what happens at full scale. Although it's no substitute for full-scale testing, where here we have a bespoke full-scale testing rig that's been developed in nCATS, and actually when you're testing at this full scale, you also sometimes need to actually just develop bespoke scanning technology, and this is what you see here, able to characterize the damage. Thank you very much for listening.